Lecture 27, Deduction of Euler theorem. Now, deduction of Euler theorem. So first, if suppose z is a homogeneous function of degree n in x and y, then the first deduction for the higher derivative is x square del 2z upon del x2 plus 2xy del 2z upon del x del y plus y square del 2z upon del y2 is what? Is n minus 1 time of that function z. So, and the second deduction, if suppose z is a function of u, is a homogeneous function of degree n in x and y, then x del u upon del x plus y del u upon del y is n time of that fu upon f dash u. So this is a deduction of Euler theorem, and more generalize that deduction, so we can write, if suppose this fu upon f dash u and fu upon f dash u is suppose say phi u function, then we can write x square del 2u upon del x2 2xy del 2u upon del x del y y square del 2u upon del y2 is what? Is phi u into phi dash u minus 1. Here phi dash u is what? Is a derivative of that phi u function. So these three basic deduction which we will use in solving the problems. Now take an example. If suppose u, we have a function sine inverse, and that x plus 2 y plus 3z upon root x power 8 plus y power 8 and z power 8, and we have to show that equation x del u upon del x plus y del u upon del y plus z del u upon del z is equal to 3 time of tan inverse u. So by the using of Euler theorem, we can easily show that identity or equation. How? Here you see that u function is homogeneous or not. First of all, you have to check that function is homogeneous or not. So u is not homogeneous, because if you replace x with xt, y with yt and z with zt, so you cannot take t as a common outside the sine inverse. So this function we cannot say is a homogeneous, but if you see that function, if you take that sine inverse on the left hand side, so you write that function, we rewrite the function, given function, and it's what you can write sine u is equal to x plus 2y plus 3z upon root x power 8 y power 8 z power 8, and we say that sine u is what? Is f u function. So now you see, now fu or say sine u is homogeneous function. Here we say fu that is homogeneous, because you can take, if you replace x with xt, y with yt and z with zt in that function, so you take t as a common numerator and t power 4 in denominator, so we can say we common 3 raised to power minus 3, so we can say fu is a homogeneous function of order -3. So by Euler theorem, Euler state that for 3 variable, you can say x into partial derivative of fu function with respect to x plus y into partial derivative of y of fu with respect to y, and z into partial derivative of fu with respect to z is -3 time of that function fu, because fu is a homogeneous function. So we apply the fu here. So what we write, x into, and fu is what? Fu is a function, homogeneous function is a function of xyz also. So we write del upon del x of sine u plus y del by del y of sine u z del by del z of sine u and minus 3 time of sine u. Now that sine u, we have to partial derivative of that function with respect to x, so we write del upon del u of sine u into u is a function of x by z we have given, so we write del u upon del x plus y del u del upon del u of sine u into del u upon del y, and for similarly for that term z del upon del u of sine u into del u upon del z is equal to minus 3 time of sine u. Now the derivative of sine u, as you know, is cos u, so we write x cos u del u upon del x plus y sine cos u del u upon del y and plus z cos u del u upon del z is equal to minus 3 time of sine u. Now on the left hand side you see cos u take as common and put in the denominator of the right hand side. So the remaining equation we get x del u upon del x plus y del u upon del z plus z del u upon del z is equal to what? Minus 3 sin u upon cos u, and sin upon cos we write minus 3 time of tan u. So this is the required proof. In that way we can simplify. So here you have to remember the function, the given function we cannot say is a homogeneous. First we take the left hand side, then the coming function we can say is a homogeneous because we can take t as a common in that function if we put x with xt and y with yt. So we can say that fu is a homogeneous function of order what? Minus 3. So Euler stated that x partial derivative of that function with respect to x plus y partial derivative of that function with respect to y and plus partial derivative of that function with respect to z is what? 3 time of that function. So use that concept, you can simplify or show that equation by using Euler theorem. Take one more example here. Suppose we have u is equal to sine inverse x plus y upon root x root y. So we have to prove these two identities. So first, as similar in the previous example, that u is what? We cannot say it's a homogeneous function because we cannot take t as a common, or we cannot define the order of that function. So we write that function, we write first of all we say u is not homogeneous here, but you can say sine u is equal to x plus y root x plus root y. So that sine u, that is fu, is homogeneous of what? Of order, if we take x with xt, y with yt, so we can say sine u or fu is homogeneous function of order or degree which is 1 by 2. You take t as a common and denominator and numerator, so we get the power t 1 by 2. Now by Euler theorem for two variable, because we have in that question we have two variable x and y, is what? X into del upon del x of function fu, because fu is homogeneous, y del upon del y of fu is what? Is 1 by 2 time of fu function. Now x into del upon del x, and what is fu? Fu is sine u plus y del upon del y of sine u is equal to 1 by 2 sine u. Now that function sine u, and we have to take partial derivative with respect to x, so we use the chain rule and use a function of xy. So we write del upon del u of sine u and u with respect to x, y del upon del u of sine u and u with respect to y is equal to 1 by 2 sine u. Now take the partial derivative, sine u become cos u. So we get x cos u del u upon del x plus y cos u del u upon del y is equal to 1 by 2 sine u. Now take cos u as common in the left hand side and put it into the denominator of the right hand side. So we write x del u upon del x y del u upon del y is equal to what? 1 by 2 sine u upon cos u, and this become 10, which is the required proof, first proof. This is the first identity proof. Now for the second part, for proof the second part, what we take? We just take that u, tan u as a function phi u. Take phi u is equal to 1 by 2 tan u. So by deduction of Euler theorem, as we discussed previously, so here u is a function, fu is a function of xyz, and if you suppose this is a z function, u is a function of xy, and fu is a function of what? Again xy, and the homogeneous function. So here we use the deduction of the Euler theorem is what? Higher order deduction, x square del 2u upon del x2 plus 2xy del 2u upon del x del y plus y square del 2u upon del y2 is what? Phi u and phi dash u minus 1. So we just substitute on the left right hand side. Phi u is what? 1 by 2 tan u, and the derivative of tan u is what? Sec square u. So we write 1 by 2 sec square u minus 1. On simplify that term, we get what? That is sine u minus sine u cos 2u upon 4 cos cube u. So we just apply the some trigonometrical identities and simplify, we get the right hand side, and in that way we, by the using of deduction, we can directly prove that second identity. Now take one more example. If suppose u is equal to tan inverse x cube upon x cube plus y cube upon x minus y, then we have to prove these two identities. So here we use the Euler deduction formula. So as you see, u is equal to tan inverse x cube plus y cube. We cannot say this is the homogeneous function of particular order. So we take that tan inverse on the left hand side and write tan u is homogeneous function of order what? 2. We get an order 2, and tan u is what? We can say that is fu. So fu is equal to tan u is equal to x cube plus y cube upon x minus y. Now if you see there, here that fu is a homogeneous of order 2 in x and y. So by Euler theorem, here we use the deduction of Euler theorem. Here fu is tan u, and tan u is what? X cube plus y cube. So we can write directly x del u upon del x plus y del u upon del y is equal to n time of fu upon f dash u. So here we just solve the right hand side. N is what? The order is 2 into fu is tan u, and the derivative of tan u, we write sec square u here, and after solving that particular tan u, we convert it into sine cos, and using the sine cos we get sine 2u. So this is the first proof by using Euler's theorem deduction. This is why. Now for the second part, you just take that sine u as a phi u and using the deduction for higher order, and which is x square del 2u upon del x2 2xy del 2u upon del x del y plus y square del 2u upon del y2 is what is phi u phi dash u minus 1. Here phi u is what is that function. So we just put on the right hand side, so we get sine 2u, and the derivative of sine 2 is 2 cos u cos 2u minus 1. After multiplying, you get 2 sine 2u cos 2u minus sine 2u, and this become sine 4u minus sine 2u. Now apply the sine a minus sine b, formula of sine minus sine b, we get 2 time of cos 3u, that is 4u plus 2u by 2 into sine u. So this is the right hand side, and we get the required proof, that is part 2. So in that way we use the deduction, and by the help of deduction formula of Euler theorem we can easily simplify